I'm going to be discussing an experiment called a rather large thermometer. The purpose of this experiment is a homemade thermometer is used to reinforce the concept of expansion and construction use of a thermometer. The materials needed for this experiment is a 500 milliliter Erlenmeyer flask, a 1-hole rubber stopper, a 1 meter glass tube, distilled water, food coloring of your choice, and a hot plate. And a question for thought: why does the liquid in the glass thermometer initially drop when heated and raises when it is cool? So first, I had to make a hole in a rubber stopper the side of the glass tube, and then I filled the Erlenmeyer flask with water, and my food coloring choice is red. So now I'm filling the glass tube halfway up, so I'll be able to see and mark the initial point of where the liquid starts. But I didn't have the rubber stopper all the way in, and I kind of spilled on myself. So make sure you're careful to put the rubber stopper all the way in so the liquid doesn't come out, and keep paper towels around in case you do the same thing I did. So now as I put the rubber stopper back in, I made sure that it's all the way down, and I continue to fill the glass tube up far enough so I can be able to see it. And I mark the level of where the liquid starts, so I have a point, initial point. And while I'm doing this, I have a hot plate that was preheating a couple of minutes before. And now, as I'm heating the liquid, it initially falls and doesn't immediately raise because it is due to the fact that the thermal energy first must pass through the glass to reach the liquid. Glass has a relatively high specific heat capacity with respect to the liquid. As a result, the glass will expand before enough heat is transferred into the liquid. Since the glass expands, the internal volume of the thermometer increases. Thus, the level of the liquid falls. The coefficient of expansion for solids, however, is generally smaller than for liquids. So once the liquid begins to absorb heat, it expands faster than the glass container, causing the liquid to rise. So as you can see, the liquid is rising now, and I let it go for maybe a minute or so. And then as I'm getting done, I mark the final point, and I have ice by to help with the cooling process. So I put the Erlenmeyer flask on ice, and as it begins to cool, the initial temperature rises because upon cooling a glass thermometer, heat leaves the glass faster than heat from the liquid can transfer through the glass, leaving the glass with a net loss of heat. As a result, the glass contracts and the interval volume of the thermometer decreases. Thus, the level of liquid rises. Eventually, The liquid contracts faster than the glass, and the level falls as the temperature falls.